Okay, so here we have limiting and excess reactants, and we're going to consider this lovely cheese sandwich. It looks like something a small toddler would enjoy. You know, they're like their food very plain. 2 slices of bread and 1 slice of cheese makes 1 sandwich. Now, I made the sandwich a little weird because you needed to be able to still see the cheese. Okay? Now, what if I gave you 3 slices of cheese and an unlimited supply of bread, as much bread as you could ever need? How many sandwiches could you make? 3. Don't you like this so far? Pretty easy, yes? If I gave you 4 slices of bread and an unlimited supply of cheese, how many sandwiches could you make? 2. Now, if I gave you 3 slices of cheese and 4 slices of bread, which substance limits the amount of sandwiches you can make? The bread. So this is the concept. The bread is what we call the limiting reactant. It limits how much product we can make. So in order to solve a problem like this, where I give you an amount of substance A and an amount of substance B, and I'm like, how much C can you make? You would find the amount of product you can make from A, the amount of product you can make from B, and you would say, what's the smaller amount? And that's the smaller amount. Okay? So basically, it's kind of like you just have to do 2 calculations and you pick the smaller number. Okay? So the bread limits the amount of sandwiches. It's called the limiting reactant. Sometimes you will hear it called the limiting reagent. A reagent is just a different word for a reactant. Okay, so don't get scared if you hear that word. It just means reactant. Now we also have a name for the substance that is left over, and it is called the excess reactant because we have an excess of it. We have more than enough. Okay? So the one that has leftover is called the excess reactant. Consider this weird little thing here. We've got this sort of square shape and a triangle shape, and they react together to make square triangle. Draw what will be present after the reaction takes place. What will we have? So make a little drawing. What else should I have in here? I should have 3 triangles left over, yes? So who is the limiting reactant? The square is the limiting reactant, and the triangles are, what do we call those ones? Those are the excess reactant. Excellent. So what is the limiting reactant? That is the square. What is the excess reactant? Those are the triangles. So there we go. So basically find the amount of product that could be produced by each reactant. So you do the calculation twice. You do 2 calculations. and you pick the smaller amount. Now, what do we call that smaller amount? That is called the theoretical yield. The reason it's called theoretical is because it is the amount that you could make, the maximum amount you could make in theory. Okay? Now, let's say you were back making the sandwiches. Okay? We're just going to go back here for a second. All right. So in theory, with 4 slices of bread and 3 slices of cheese, you could make 2 sandwiches, yes? Now, what if somebody sneezed on one of those slices of bread? Then we would only make 1 sandwich, right? So we're now no longer in the calculating the perfect amount of sandwiches we could make from this. Now we're in the real world where stuff happens, yes? In the real world, when you're doing a chemical reaction, you might not sneeze in your chemicals, but you might accidentally spill some. The reaction might not be a perfect reaction, like where everything reacts. You might have some little side reactions going on. You might have something that's a little bit impure. So very often the amount of product you get when you do an experiment will be different from the theoretical amount. Does that make sense? Okay. But for now, we are only concerned about the calculated quantity. So the smaller calculated product is the theoretical yield. Thank you. Make sure everyone's here. Oh, we're off. Okay, Christy, Wilfred, Sky. All right, now we're actually going to do some calculations with chemicals. So in example number 3, we are starting with 6 moles of H2, and we want to know how many moles of H2O. When we go from moles to moles, would you guys be able to do that calculation yourself? Give it a try. Okay, and you'll also do part B. Once you've finished your calculations, you can check and see if you got the same thing as I did. But finish your own calculation first. And then see if you can answer C using the knowledge that we just learned. So we did calculation number 1, got 6 moles. Is anyone wondering where I got these numbers from, the 2 and the 2? Everyone good with where those came from? Okay. And everyone's good with where the 2 and the 1 came from? Okay. So how much H2O can actually be formed? What's the theoretical yield? You have a choice. It could be 6 moles or it could be 8 moles. Which one is it going to be? 6, because if I take the H2, I will run out of H2 before I can manage to make 8 moles. Yes? So how much can we make? 6 moles. This is the smaller amount of product. Which reactant is limiting? Tell your partner, which reactant is the limiting reactant? So who limits the amount we can get? The H, okay? That's what we started with to get the smaller amount. So H2 is the limiting reactant. What do we call the oxygen? We call that the excess reactant. So the O2 is in excess. Now, this is just so you don't get confused. There's no actual point to this question. I would not ask you this on a test, okay? But sometimes people think, I have only 4 moles of O2, therefore and 6 moles of H2, therefore O2 must be the limiting reactant because I have a smaller amount. And that is wrong. Okay? And the reason that it's wrong is that we use more H2 than we do O2 to make the water. We use twice as much H2 as O2. So in order to use the same amount, I would have to have twice as much H2. I would like those would be equal stoichiometric amounts. Okay? So the smaller amount of reactant, it might be the limiting reactant, but it also might not be the limiting reactant. So don't make that mistake. Okay? So you can't tell who is the limiting reactant by just looking at the moles of reactants. How do you know which reactant is limiting? Yeah, you look at which reactant produces less product. The reactant that produces less product is the, and I'm going to start abbreviating it because limiting reactant is really long to write. I'm going to start calling it the LR. Okay, that makes our life a little bit easier. Example 4. We have 12 moles of H2. Oh, I should highlight our reaction here. We have 3 H2 plus N2 gives 2 NH3. And we're going to mix 12 moles of H2 with 6 moles of N2. Can you look at that and say 6 moles of N2, that's smaller, that must be the limiting reactant? Can you do that? No. What should you be finding to figure out how much product will actually be formed? You should be finding the moles of product from each reactant. How many calculations will that be? 2 calculations. Do you guys think you could do it? So you're doing the 2 calculations in parallel with each other. For one of them, you're starting with H2, and the other you're starting with N2. All right, but for both of them, you are trying to find the moles of NH3, which is the product. All right, and so you cancel your moles of H2. In this one, you cancel your moles of N2, and for both of them, you find your moles of NH3. So if you use up all of the H2, you'll make 8 moles of NH3. If you use up all of the N2, you'll make 12 moles of NH3. Who runs out first? H2 or N2? We run out of NH2 first. So that means that H2 is the limiting reactant. Yeah. Yes, of course. And the excess reactant is the N2. And if we want to find our theoretical yield, we pick one of these two numbers. Which one do we pick? We pick the smaller one. So it's the 8 moles of NH3. So our theoretical yield is 8 moles of NH3. Is that good? Okay, awesome. Oh, and that's it for that one. We have 5 more minutes. We can start on this. We'll start on it. Okay. Consider the following balanced reaction. Here's our cheese sandwich again. And once again, we have 3 slices of cheese and 4 slices of bread. This is on page 45. Okay. Earlier, we determined that the bread was the limiting reactant and the cheese was the excess reactant. How much cheese do we have to start with? 3 slices. How much cheese is used up? 2 slices. How did you know that? You can say, I make 2 sandwiches. 2 sandwiches need 2 slices of cheese. So that's one way you can say it. And number 2, you could also say 4 slices of bread require 2 slices of cheese. So basically, what you're going to be doing is you're either going to be using the smaller number for the product and finding out how much excess reactant you use up, or you're going to be using the limiting reactant and saying, how much do I use up reacting with the limiting reactant? How much cheese is left over at the end? 3 minus 2 is 1. How did you figure out how much cheese gets used up? You're going to figure it out either from the number of sandwiches or from the slices of bread. How do you figure out how much cheese is left over? You take the cheese at the beginning and you subtract the cheese used up by the bread, the limiting reactant, and that's going to equal the cheese left over. Is good? Wonderful. Just stick your name on it. Sorry. There you go. All right. This is just the answer. So basically, to find the amount of excess reactant left over, this is on your next page, you take the excess reactant at the start and you subtract the excess reactant used. How do you find the excess reactant used? You calculate from the limiting reactant. Is good? Okay. Okay, so that's on your next page. That's at the bottom of the page. How much do you have at the start? How much have you used up? How do you find out how much used up? You calculate it from the limiting reactant, or you can calculate it from the smaller amount of product. Your choice. And the reason is that you get the smaller amount of product from the limiting reactant. So those numbers are essentially the same. They're just in different units. Okay? This is page 46. Okay. You know what? I would like to skip this one and go right to the numbers. Okay, so this is on page 48, down at the bottom. Consider the following reaction. 2H2 plus O2 gives 2H2O. On the previous worksheet, we determined that when 6 moles of H2 reacts with 4 moles of O2, H2 was limiting and O2 was excess. We figured that out previously. How many moles of the excess reactant are needed to react with 6 moles of H2? Well, that's just how many moles of O2 are needed to react with 6 moles of H2. Remember, that's our limiting reactant, and we're calculating the excess. Excess stands for excess. So this is the excess used. We start with our limiting reactant and we convert it into our excess reactant. So we have 1 O2. Don't move. I need to send you away with something to do for the weekend, so we're going to give you your homework before you leave. 2 moles of H2, and we get 3 moles. Don't move. Don't put your book away. I will sit here until we're done. Don't put your calculator away. Don't put your book closed. You're still writing. 3 moles of O2. How many moles of O2 is left over? Right? We started with 4 moles of O2. That's at the start. And we subtract 3 moles of O2. That's how much was used. And that equals 1 mole of O2 left over. And what I'm going to assign you for homework is all the rest of this one. So that would be pages 49, 50, and stay out. Thank you. 49, 50, and I would actually really love it if you would also do 7.1e on your own. Okay, so 49, 50, and 7.1e. There we go. Thank you. Thank you for your patience. I'm sorry I ran over. And I'm sorry I yelled at you all. Sit, stay. I felt like, oh, anyway, bad.